everybody. Today we are going to learn how to find the area of a rectangle when it has decimal dimensions. Very similar to what we did last week when we found the area for rectangles that had fractional dimensions. Just like with last week, I'm going to start with a quick review of what area is. Area is the surface space on an object. So how much space is taken up on the flat surface of an object? How many square units are on a surface is what we're trying to figure out when we look for area. And that means that we measure in two-dimensional units. So inches squared, units squared, meters squared, whatever it is that we're measuring with, because our answer is how many of these squares that have a length and a width are there on our object. We are going to do practice problem number 1 from your assignment today, which is giving you the length of 5 3/10 inches and the width of 1 7/10 inches for a rectangle and asking you to find the area. So let's go ahead and start, just like with perimeter, by copying down the rectangle, copying down the dimensions, giving ourselves lots of space. We should be using lined paper if possible so that we can keep our computations lined up. We also want to start by reminding ourselves what the formula is for area. To find area, we multiply the length times the width. So we actually have all the information that we need already labeled on our rectangle, and we don't need to write in the other dimensions. Our very first step, once we've written down the problem and reminded ourselves of the area formula, is to plug in the length and the width for our rectangle into this formula and write a multiplication problem. So in this case, the area of this rectangle is the length, 5 3/10 inches, times the width, which is 1 7/10 inches. I'm next going to move on to solving that problem in step 2. So my step 2 is solving the problem. And just like with the addition with decimals when we found the perimeter, I want to make sure that we're turning our paper sideways so that we can keep all of our place values lined up. It's not as important that the decimal has its own space when we multiply decimals because we are actually ignoring the decimals to start with, but we do want to make sure that we keep everything lined up. So let's write our problem, 5 3/10 times 1 7/10. Remember, when we multiply decimals, we're ignoring the decimal point at first, and we're just starting with the ones place times the ones place and proceeding with typical multi-digit multiplication. 7 times 3 is 21. Put the ones place here, regroup the 2. 7 times 5 is 35, plus 2 is 37, and I'm going to cross out that 2 because I want to make sure that I don't reuse what I regrouped accidentally. Okay, now we're going to move down to the second partial product, put a place marker in, move on over to the second place value, the ones place, or if we're ignoring the decimal, the tens place in our bottom factor. 1 times 3 is 3, 1 times 5 is 5, and then I'm going to add up my partial products. 1 plus 0 is 1. 7 plus 3 is 10. I'll regroup that 10 over here. 5 plus 3 is 8, plus 1 is 9. And now we're going to deal with the decimal point. Because there are 2 decimal places in my factors, I'm going to make sure I put 2 decimal places in my product. Okay, so my answer, the area of the rectangle, should be 9 1/100 square inches, but of course I want to make sure that I check that. I'm going to show you how to check using the inverse operation, which here is division. So we're going to check by dividing 9 1/100 by one of the factors from my multiplication problem. I'll choose 1 7/10. But remember, we do not want a decimal point in our divisor, so I'm going to move it one place to the right so that I'm working with the whole number 17. That means I also need to move the decimal the same number of places in my dividend. So I'm going to move it over here and bring it on up to my answer line. Next, I'm going to proceed with typical multi-digit long division. I like to write the mnemonic device, Dracula's mother sucks blood, off to the side to remind myself how to do that. Or you could write the symbols, divide, multiply, subtract, bring down. Okay, so first I'm going to ask myself, how many times does 17 go into 9? It goes in 0 times, and because everything's nice and lined up, I'm just going to skip to the next place value over. How many times does 17 go into 90? I'm going to have to do some estimation and guessing and checking over here. I know that 15 times 5 is 75, and that's kind of close to 90, and because 17 is bigger than 15, I'm going to check 17 times 5. 5 times 7 is 35. I'll regroup the 3. 5 times 1 is 5, plus 3 is 8. 85. That's pretty close to 90. I can't fit another 17 in there without going over because there are only 5 more ones to get to 90. So that means that 17 goes into 90 5 times without going over. 17 times 5, I did that work over here, is 85. So now I have divided and I have multiplied. Now I need to subtract. 90 minus 85. Let's regroup. 10 minus 5 is 5. 8 minus 8 is 0. Is 5. I have subtracted. I'm going to bring down the 1. And I brought it down. Okay. So now I'm asking myself, how many times does 17 go into 51? Well, I know that 15 times 3 is 45, and that's kind of close to 51, and 17 is bigger than 15. So I'm going to guess maybe 3 times. Let's check. 17 times 3. 3 times 7 is 21. I'll regroup the 2. 3 times 1 is 3. Plus 2 is 5. Exactly 51. So that means, and I've divided again, 17 goes into 51 exactly 3 times. You multiply. 17 times 3, I know I did that work over here, is 51. I'm going to subtract. 51 minus 51 is 0. I have no remainder. And the quotient is 5 3/10, which is my other factor. So that means that my math work on the multiplication was correct. I've checked my work, and I can wrap it up. Step 3, don't forget to check your work. We just did that. You can use the inverse operation, which is how we checked it, or you could use a second strategy. And lastly, we're going to write in our answer, making sure it's the correct unit. The area of rectangle for problem number 1 is 9 1/100 inches squared. Square units for area. And now we have the area for our first rectangle on our practice page.